graphing quadratics by hand. Why might we need to do it by hand? Yes, Desmos will do them for us. In life, you may come to a point where you don't get to use the calculator, which seems kind of extreme. Like, why would I never get to use the calculator? Well, maybe you've taken the SAT already, or maybe you're planning on taking the SAT. There's two math portions on the SAT, and one of those math portions is non-calculator. Like, you just don't get to use the calculator at all. Not even a calculator that will just add and subtract. Like, you don't get to use it. So there's that. And then there's like calculus. You may get to a point where you're taking calculus, maybe in high school, because some of you are in 10th grade, and you would be on track to take calculus in high school. Most of the AP calculus exam is non-calculator. And you may need to know what, like, hey, what does this graph kind of look like? And that's kind of what we're going to go over today. What would this graph kind of look like if I didn't have a graphing calculator or Desmos to graph it on? So we got standard form ax squared plus bx plus c, or factored form, like it's already been factored for you. To find the x-intercepts, you guys got to write a lot more today because a lot of you play on your phone and not pay attention, and then you do really bad on the quick checks. So you're going to write a little bit more down today, so maybe you won't play on your phone as much. So to find the x-intercepts, this is literally what we've already been doing. The x-intercepts are the solutions to the equation. Solutions to the equation. Literally, like we set that equation equal to 0. We solve for x. We've been doing that for a really, really, really long time. We did Who Killed Mr. Quad back there on the back. Guess what? Every single one of those numbers on that wall represent. We didn't call them this at the time, but every single one of those numbers was an x-intercept where the graph crossed the x-axis. So let's draw a parabola, just so we can kind of do like some definition kind of stuff. And let's draw maybe an x-axis. We didn't put the y-axis on here yet. That's okay. The x-axis. Where this graph crosses the x-axis, those two things would be considered x-intercepts. So we would consider those things the x-intercepts. And if we can find those, we can sketch a pretty good graph if we can find those two things. Literally, the solutions to the equation, maybe we want to throw some equal to 0 in here. You would just take the equation like x squared plus bx plus c equals 0. Okay. To find the y-intercept, we're going to plug in 0 for x. Why might we plug in 0 for x in order to find the y-intercept? In case you really wanted to know, the y-axis may be like right here, maybe. So this is going to be our y-axis. And every single point on that line, every single point on the y-axis has something in common. And what they have in common is that the x value of every single one of those points is 0. So if I were to pick this point right here, which is the y-intercept, what is the x value of that point? 0. So if I know the x value has to be 0, I can use that to find the y-intercept. All right, what is the axis of symmetry? We talk about axis of symmetry. There's all sorts of axis of symmetries in real life. If we were to say, hey, your face is perfectly symmetrical, well, what would the axis of symmetry be? It would be that line that goes like right down the middle of your nose that divides the left and right, which makes it symmetrical, right? It would look real funny if your face was like symmetrical over here, like inside your eye, which means your nose, your ear would be here. It would just be really funny. But the axis of symmetry right down the middle. So that's the idea here. Is this line that separates like the middle of the graph. If we do put this on the graph, we would normally use a dotted line to represent it, because it's not actually part of the graph. It is a reference line, and when we draw those lines, we normally use a dashed line because it's not actually part of the graph. It's just there for reference. So if we were to fold our graph along those lines, it would be symmetric. And if it's in standard form, if our equation is in this form, we can find it using x equals negative b over 2a. Maybe you remember that from Algebra 1, because you should have done this in Algebra 1, perhaps. And maybe you've seen that negative b over, like, man, I've seen that before. Like, that's just part of the quadratic formula, really. You got negative b plus or minus the square root of all this other stuff, right? And then what's on the bottom? 2a. So what's the plus or minus give me? The plus or minus gives me the x-intercepts. And why do they give me the x-intercepts? Because the axis of symmetry and this idea of the vertex is actually halfway, so this distance and this distance are actually equal. So the axis of symmetry is actually halfway between the two x-intercepts. And we can use that idea to help us find the vertex or the axis of symmetry in factored form. Since it is halfway between, what number is halfway between two numbers? Well, that's the average. So we can really just find the average of the x-intercepts. We can literally just find the average of the x-intercepts. Because if it's already in factored form, finding the x-intercepts are going to actually be really simple. So our factored form, x minus p. So p would be the x-intercept, and x minus q. So q would also be the x-intercept in this case. What is p and q? P and q are just some random numbers, okay? They represent the factored form, and if we change the sign, we get the x-intercepts. So how might we find the axis of symmetry if we know the x-intercepts? Well, we're just going to find the average of two numbers, which is literally just adding those two numbers together and dividing by 2. So we're just going to add those two numbers together and divide by 2. All right, what is the vertex? I put this line on here, this point on here, because I thought we were at the vertex, but we weren't quite there yet. At that point at the bottom, the very bottom of the graph, that separates the two halves, the very, very tip of the graph or the top, if it were to open up, it would be at the top. We call that point the vertex. And how do we find that? Well, the x value, because it is on the axis of symmetry, the x value is the same as the axis of symmetry. So the x value is the same as the, I'm going to do some abbreviating here, axis of symmetry. And how do we find that? Well, if you want, you can just draw an arrow back up to the two things we wrote right above it. The average of the x-intercepts is going to be the x value of the vertex, or x equals negative b over 2a is going to be the x value for the vertex. How do we find the y value? Anytime we know the x value, we can find the y value just by plugging it in. So we're going to plug in the x value. We're going to plug in the x value to find the y value. We're going to plug in the x value to find the y value. So if we know, hey, the x value is 3, we're just going to plug 3 in. Hey, the x value is negative 8. We're just going to plug negative 8 in. We're going to do number 1, number 2 today. We're going to do number 3 tomorrow. So we'll do 1 and 2 today. 1 and 2 are already in factored form. X minus 1, x plus 2. X minus 1, x plus 2. So if it's already factored, what would the solutions to the equation be if we set it equal to 0? Well, a lot of you are like, well, you just switch the sign. Yes, just switch the sign. So x equals 1 and x equals negative 2. So that's where our graph would cross the x-axis. We're not going to graph these yet. We're going to graph some on the back. But in this case, we're just finding those things. So I found the x-intercepts for number 1. You take a second and find the x-intercepts for number 2. You try the x-intercepts on number 2. We're doing number 3 tomorrow, not today. You should have got negative 4 and positive 3. All right, let's move on. Y-intercepts. How do we find the y-intercept? Well, I know anything that crosses the y-axis, the x value there is going to be 0. So we get y equals 0 minus 1 times 0 plus 2. And then all we have to do is maybe figure out what that equals, type that in the calculator if you need to. 0 minus 1 is -1. 0 plus 2 is +2. And -1 times +2 is -2. You figure out the y-intercept for number 2 now. And again, we're going to do number 3 tomorrow. So you figure out the y-intercept for number 2. And if we can find these things, we can draw a really, really good graph of a quadratic by hand. A really good graph by hand, if we can find these things. And the more of these things we find, the better our graph is going to be. We just find the x-intercepts, we get a decent graph. We find the x-intercepts and the y-intercept, we get an even better graph. But if we find the x-intercept, the y-intercept, and the vertex, we get a really good graph. So for the y-intercept, you usually got y equals 0 plus 4 times 0 minus 3. That's 4 times -3. And 4 times -3 is -12. For the x-intercepts, yes, but not for anything else. So when we do the y-intercept, we're plugging it back into the original equation, which is before the signs were switched. The axis of symmetry, we can find it 2 ways. It's already in factored form. I don't want to multiply this out just so I can do -b over 2a. It's already in factored form. So we're going to take the average of the x-intercepts, 1 plus -2 divided by 2. What number is halfway between those two? Because we said, hey, the axis of symmetry is going to be in the middle, and all those points are going to be symmetric, the same distance away. So if we're talking about the x-intercepts, axis of symmetry are going to be halfway between those two. So 1 plus -2 is -1, and -1 divided by 2 is -1/2. You try the axis of symmetry for number 2. You try the axis of symmetry in number 2. Add up the x-intercepts and divide by 2. Use a calculator if you need to. You can write these as decimals or fractions. Because when we start graphing, we're probably going to want to change them to decimals, especially if we get something like 27 over 2. Hey, what's that look like? Change that to a decimal, and then we'll be able to graph that.
It says x equals -b over 2a, so you don't have to do anything with that negative.
If we're using the -b over 2a, that's if it were in standard form, and all of ours are in factored form so far. So if our equations looked like this, the ax squared plus bx plus c, then we would use -b over 2a.
Okay.
But since ours look like this, it's really easy to find the x-intercepts, and we can just average them together. So we actually didn't use the -b over 2a. In this case.
Why intercept you use the ones at the top, but in this one, the axis of symmetry, you use the y.
Yes, because with the y-intercept, we're plugging 0 into the original equation for x. The axis of symmetry, we are averaging the x-intercepts together. So the x-intercepts are -4 and 3. We do want to average those together. And then we get -1/2 also. Purely coincidence that we got the same answer here. Literally just, I typed these 2 questions up, did not work them out until I realized that they were equal. All right, how do we find the vertex? How do we find the vertex? Well, the vertex has an x and a y value. We've already found the x value for both of these. It just happened to be -1/2 for both. So anytime that we know the x value, like with the y-intercept, we knew the x value was 0, we plug that number back into the original equation. So now I know the x value is -1/2. How can we find the y value? We plug it back into the original equation, just like we plugged in 0. So -1/2 minus 1 times -1/2 plus 2. So we were looking for the point on the graph when x equals negative 1/2. So we were trying to find the y value for that. You can use a calculator if you need to. And then if we're going to graph it, you probably would want to change your answer to a decimal. And we're about to graph in just a second. Type that in the calculator, you get -9/4. Right, how am I going to put -9/4 on the graph? That's a point on the graph, but I don't really know where -9/4 is. But you hit the button on your calculator, that'll change it to a decimal. I know where -2.25 is on the graph. The button on your calculator, the TI-30, is the one right above the enter sign with the 2 arrows. And it'll change the fraction to a decimal, or it'll change the decimal back to a fraction. The one right above the enter button. It's got the 2 arrows pointing in opposite directions. If you hit that, it'll change it decimal, fraction, fraction, decimal. Every time you hit it, it'll change it to the opposite. All right, you try the y value for the vertex in number 2. And then I'll tell you what the answer is. We'll graph 2 things today. We're not going to have a whole lot of time to do classwork today. So tomorrow, we're going to spend most of tomorrow working on practicing this idea. And then we will look at those that instead of given factored form, they were given in standard form, like number 3. But all the ones in standard form that I'm going to give you, you should be able to factor those. You should be able to factor those. So for the vertex, y equals -1/2 plus 4 times -1/2 minus 3. Type that in the calculator, you get -49/4. You should have got -49/4 if you wrote the fraction down, and the decimal for that would be -12.25. I don't really care which one you write down at the moment. They're the same thing. If we're going to graph it, we probably need the -12.25. Any questions there? All right, so graphing, if we find like one thing, we'll get an okay graph. But the more of these things that we can find, the better our graph's going to look. In this case, we got x minus 4 times x minus 1. Maybe from algebra 1, you remember, hey, I know when the graph opens up or when it opens down. And it's based on that very first number. If that number in front is positive, the graph's going to open up. And if that number in front is negative, the graph's going to be reflected and it's going to open down. So this number in front, there's actually not a number there, but that number is positive. It's a +1. And since that number is positive, the graph's going to open up. And just a basic sketch of the graph, it is a parabola. It is going to look something like that. So now, if that's all I knew, I could draw like an okay graph. Like, hey, I know it opens up, but where's it going to be on the graph? Infinitely many possibilities for that. So then I can start finding these things, and then that's going to, each thing I find is going to make the graph look that much better. So the x-intercepts in this case, yes, we can literally just switch the signs. So x equals 4 and x equals 1. We can go ahead and put those on our graph, x equals 1 and x equals 4. So we have 1 here and we have 4 here. So we can go ahead and start adding these things to our graph. Now, don't actually draw this, just watch. If that's all I knew, hey, the graph opens up and x equals 1 and x equals 4. Here's what could happen. The graph could, don't draw this again, because this may or may not be right. The graph could look something like that, right? But there's other possibilities here as well. The graph could also look something like that. And while those both open up and they both cross the x-axis at 4 and 1, these graphs are drastically different. Which one's right? There's actually infinitely many possibilities that we could sketch at this moment. Like, hey, I could go in a little bit in between, or I could go a little bit further down, or I could go a little bit steeper. Like, there's like infinitely many possibilities that we could draw at this point. Which one is it? So yes, we get a pretty good idea of what it looks like just by those two things. Does it open up and the x-intercepts? But if we start finding these other things like the y-intercept, then there's not really going to be an issue like which graph is it? Like we're going to know. So let's find the y-intercept. Y equals 0 minus 4 times 0 minus 1. Type that in the calculator if you need to, but 0 minus 4 is negative 4. 0 minus 1 is negative 1. And negative 4 times negative 1 is positive 4. So we know we're going to cross the y-axis at positive 4. So now that's starting to limit what these graphs could look like. I know the graph's got to go through this point now. Don't draw this again, because I'm going to just erase it. So I know the graph has to go through that point. So the graph's got to look maybe something like that. But then we also have the issue like, how far down is the graph going to go? So I could do the same thing, but maybe the graph went down further. Does that make sense? So now the possibilities are not as abundant, but there's still an issue here. I don't know how far down the graph's going to go. So maybe if I find the axis of symmetry, specifically the vertex, then I'm going to have a really, really good idea what this graph's going to look like. So the axis of symmetry, we can just average the x-intercepts together. And it's okay if you get a fraction. It's okay if you get a decimal. 4 plus 1 is 5. And 5 divided by 2 is just 5 over 2, which as a decimal would be 2.5. 2.5. Now, if we want to find the y value of the vertex, we can draw this on here if we want. Like this dotted line going through 2.5. You don't have to put that on there, but it may help. Now, to find the y value, we're going to plug, just like we plugged in 0, we're just going to change it to 2.5. So 2.5 minus 4 and 2.5 minus 1. Write that in the calculator if you need to. 2.5 minus 4 and 2.5 minus 1. And we get negative 2.25. So now I know exactly how far this graph's going to go down. So at 2.5, we have the vertex right here at negative 2.25. So now we got a really, really good idea what this graph's going to look like, especially the left side. So I know the left side's got to go through the vertex, through the x-intercept, through the y-intercept, and it's going to continue to go up. What about the right side though? See how there's only 1 point on the right and we had 2 points on the left? Well, guess what? We can add another point on the right. And it goes back to this idea of symmetry. That y-intercept is going to have a point that is symmetric to it on the other side of the axis of symmetry. So we are like 1, 2.5 away. So if I go a half, 1.5, and 2.5 away, there's going to be a point right there, the same distance away from the middle of the graph at the exact same height. So we can put that point on there. And now we can sketch a really, really good graph by hand, in this case, of this quadratic equation. That's a pretty good graph there. Pretty detailed, pretty accurate. It's not just floating around in space. We have it about where we need it to be. All right, cool. Let's do one more today. I'm going to go through this one a little bit quicker, because at this point, like the x-intercepts, the y-intercept, finding those, we should be okay with finding those at this point. I know that this graph's going to open down. And how do I know it's going to open down? It's going to open down because that is a negative. So opening down is going to look something like this. Opening down, graph's going to look something like that. X-intercepts would be at -6 and -2. So we'll go ahead and put those on the graph. Again, we can sketch a pretty good idea what this graph's going to look like, but it wouldn't be super accurate at this point. Like how far up does it go? How far out does it go? All that good stuff. So if we find these other things, then we may be able to actually tell more detail, or the detail, may be more accurate in this case. So to find the y-intercept, we're gonna plug in 0. 0 plus 6 is 6. 0 plus 2 is 2. 6 times 2 is 12. And 12 times negative 1/3 is the same as 12 divided by negative 3. Or just type all that in the calculator, and we get negative 4. So we're gonna cross the y-axis at negative 4. The axis of symmetry is going to be halfway between the negative 6 and the negative 2, halfway between the x-intercepts. If you can just look at that and be like, hey, I know that this number's halfway between those, you can just look at it and figure out what those numbers are. And that number in this case is negative 4. So if we wanted to put that on here, we could just dash the line. That's where my symmetry is going to occur. The left and right side of that line are going to be identical. Symmetric would be a better word. To find the y value of the vertex, we already know the x value. To find the y value, negative 1/3 times 4, not 4, negative 4 plus 6 times negative 4 plus 2. We're going to do the same thing we did for the y-intercept, but instead of 0, we're going to put a negative 4 there. And we end up with we end up with positive 4/3, which as a decimal is like 1.333. So now we can plot that on the graph. Negative 4, 1.333. It's not going to be perfect, but we know it's going to be in between 1 and 2, and maybe a little bit closer to 1 than it is to 2. And now that's going to be a really good, accurate representation of what this function's graph is going to look like. We can still do this idea. We're 1, 2, 3, 4 away from the axis of symmetry. So 1, 2, 3, 4 away on the other side as well. So I just kind of counted there to figure that out. We are 4 away. So this point also has to be 4 away. And we're going to go up. It's going to be nice and rounded like a U, not necessarily like a V. It's not like it'll be nice and rounded, kind of like a U. And at that point, we are done with our notes today. I'm gonna go ahead and give you your class